In the previous video, we have been learned a set, definition of a set, methods of set, and the types of set. So here also we are learning one more kind of set that is called as subset. So before telling the subset, let us take one example. Suppose I have a set of suppose I will take APUC is a whole subset. So in this Acharya Institute, we can see a different kinds of departments like IC, CSE, engineering, PUC, physiotherapy, nursing, every kinds with this. So if I take has a A set, if I take it has a A set has physiotherapy, PUC, and B set has a whole Acharya Institute, what does it carry? So I can directly say that A is a subset of B, which means the physiotherapy of Acharya and a pre-university of college that belongs to the Acharya Institute only. So this is a small example I have been given in the real world. So in the same way, when it comes into a numeric way, so how can you define it as a subset? So very simple. So it is a small definition to remember. Every element of A is also in the element of B. Means what? If you want to define a set A is said to be a subset of B. Means what? Every element of A is also in the element of B. It is usually represented by A is subset of B. The symbol represents this as a subset. So for example, let us take an example here. There is a set 1, 2, 3. A set which carries 1, 2, 3 and B is a set which carries from 1 to 5. Is it a subset or not? Let us see. So according to the definition, what does it say? Every element of A. That is, let us check. Every element. 1 is there? Yes. 2 is there? Yes. 3 is there? Yes. Every element of A, it is belonging to the set B. Then only we can call it as A is a subset of B. So, every time we cannot say that A is a subset of B. Sometimes B can be also a subset of A also. So, we usually represent it as, for example, let us take A is a subset of B. A is a subset of B. This implies every element of A belongs to A, then A also belongs to B. Then A also belongs to B. So, I have told about B is a subset of A. It is possible when every element of B that belongs to A. In a simple way, we can say it has A is a subset of B and B is a subset of A. It is only possible when A is equal to B. That means both the sets is having the same number of elements and same set of elements. It may be randomly arranged or misarranged in any of the way. We call it as a equal set. This is how you study about a subset. So we have learned about a subset. There is two types of condition here when you are applying the subset. So the two conditions is a singleton set A is a subset of itself. Means what? For any element of a set A, it is itself a subset. Itself a subset. Every element of a given set is a subset of itself. For example, let us take A is equal to 1, 2. There are two elements. How can I make it a subset? You can take it as a single set for each of the elements. For example, let us take 1 is a set and 2 is a subset of A and the third one is 1, 2. The whole set you can take. But observe here, there are two sets. There is a small formula when you are defining a subset. The subset is very simple. To define a subset, there is a formula that is 2 power n. This n always represents the number of elements in a set. Number of elements in a set. Means what? For any basic set, for any base of 2, you can define the n number of elements whatever they have been given in a set. That is, let us see. In A, how many elements are there? 2 elements are there. So 2 power 2. So what is the value? 2 power 2 means you have to multiply it to 2 times. That means it gives the value 4. So according to this, the value is the 4 which defines the 4 subsets in a given set. But how many elements are I getting? Only 3 subsets. Which is the another one? That is a null set. That is a null set. So for any subset, there are 2 conditions I told. The first condition is it is a subset of itself. And second condition is null set is a subset of every set. You can take any kind of set, whether it is in 3 elements, 4 elements or 5 elements. But it is a subset of itself or any kind of null set. So how many subsets it is formed for the set A? 4 elements is formed. So this is how you define a subset. This is the whole concept of a subset. In the same way, not only a subset, there is another kind of set, that is a proper subset. That is a proper subset. So here what happens in a proper subset? There is a 2 condition you have to maintain. First condition is A is subset of B. Means what? I have told in the previous class. What is a previous thing? So what is a subset? If every element of A is also an element of B. That is the first condition. And second condition, what does it say? A should not be equal to B. Then only we can call it as a proper subset. Then only we can call it as A is a proper subset of B. Then this defines a proper subset. Very simple to remember. If A is a proper subset of B, where it is always said that A is subset of B, when it is said when A is not equal to B, then only we call it as a proper subset. So let us take an example for this as the previous only. Let A is equal to 1, 2 and B is equal to A, E, I, O, U, 1 and 2. A, E, I, O, U, 1 and 2. So first condition, what does it say? It should be a subset. Is it a subset? Obviously, the element 1 is there, the element 1 is there, 2 is also there. So the first condition satisfied. Let us check. A is equal to B. So what does it say in the equal set? Each and every element should be equal to the element of B. It is not possible. So here 2 elements are there. Here it is 7 elements are there. So the second condition fails. So therefore the given condition also it is right only. So here it fails because both are not equal. So according to this condition, both the condition is satisfying. Therefore, A is a proper subset of B. Then how can you say it has proper and equal subset of B? When both the elements are equal. Both the elements of a given set are equal. Then only we can call it as subset of both the sets are equal. So this is a proper subset. Now I have been telling about a singleton set. So what do you mean by singleton set? Singleton set. It is already given in the name only. Singleton set. So singleton set means for any element, for any set should have only one element. For example, A is equal to 1. Or any x is equal to 3, 30 or 3. It may be anything. It should carry a single element. So then it is called as a singleton set. So we have been revising of every element, every set. So how it is related to this real number. So in real number you can see n number of elements of a set. So which are those natural numbers? You can see whole numbers, you can see real numbers, rationals, irrationals and integers these kinds of, it is a whole bunch of things what we learn about the real numbers. So then how it is linked with the given set? How can I define a subset in a real set? It is very simple. So first you tell me, so what are the elements of a given set here? Real numbers. In real numbers, what are the elements will be there? Natural numbers. How it is defined, the natural numbers? It is defined by the element of 1, 2, 3 up to so on. It is an infinity. Now, the second thing is, I have been defined about integers. Yes, integers are there. So, how can you define an integer? Integer is nothing but the positive number along with the negative number including 0. So, let us take -3, -2, -1, 0, 1, 2, 3 up to so it goes on. Next, the thing is rational numbers. Yes, what is the condition for the rational numbers? It should be in the form of p by q such that q should not be equal to 0. Right. So, what is the irrational number says? Irrational number says that it should not be in the p by q form. It should not satisfy the p by q form. Then only we can call it as a irrational numbers. And the last is real numbers. In real numbers, what are all it includes? It includes all the kinds of sets. So you have been all the kinds. I have been not written one kind here. That is your whole number. Whole number. So how can you define a whole number? Whole number is defined by 0, 1, 2, 3 up to so on. So this is how you define a real number system. How can you define under a subset? Very simple. Just observe the elements. So natural numbers are there. In natural numbers, I can say it is a subset of W. Yes, I can say N is a subset of W. Why I can say it like that? Very simple. Just observe the elements in here. So according to the subset, what is the main condition? Every element of any kind of set, it should belong to the another element of a given set. Yes, 1, 2, 3 is present and W also carries 1, 2, 3 excluding this 0. I don't bother. I need, is it a subset or not? Yes, N is a subset of W. Now, again you check. Is W is a subset of Z? Yes, it is a subset. 0, 1, 2, 3 is there. So, from here it carries 0, 1, 2, 3 up to so on. Now, so N is a subset of W. W is a subset of Z. Now we check. Is this the rational number satisfies the condition or not? So what is the satisfying condition? It should be in the p by q form such that q should not be equal to 0. So if I take any element of the given set, so let us take in a integers only. I will take p is equal to -2 and q is equal to 1. I am not giving it as 0 because the condition says it should not be equal to 0. If it is equals to 0, it will turn the whole condition into a infinity. I don't want that condition. I just need to satisfy the rational number condition. So according to this, what happens? -2 by 1, which always gives the value -2. So this -2, it is included in given integers of the given conditions. Yes. So what does it means? So for any element of the given set, I can directly say it has n is a subset of W. W is a subset of integers and integers is a subset of Q. Some elements it is possible. So in a simple way they have been defined as n is a subset of Z and Z is a subset of Q. Then what about the irrational numbers? Irrational numbers, you cannot take it as √3. √3 is an irrational number, pi is an irrational number and root 5 is an irrational number. So, but you can say it has irrational number is a subset of R, but it is not a subset for Q. Q is not a subset for irrational number. It is not possible. So the condition is according to the real numbers, it includes all the kinds of numbers. But when it comes to a subset, it includes Q is not a subset of irrational number T. It is not a subset for any kind of set, but it is included in real numbers. So this is how you define a subset of a real numbers. This condition is made to remember for your examination. This condition is very important. It will define for 1 marks and as well as the fill in the blanks question. So we have been learned what are the subsets of real number. So here we are discussing the small part of the real number that is called as interval. For any kind of function, when you are defining the function, it takes an interval. So there are 4 kinds of interval. The first kind is open interval. First kind is open interval. Here what happens in a simple way I will define it. So when you are taking any kind of endpoints, it does not include in that function. In a simple way. So let us take the condition says that y such that a is less than, y is less than b. A is less than, y is less than b. So when it is defining an open interval, just observe the operands here. It is less than. So which does not carry any kind of equal signs. It is just a simple less than integer, a less than inequality that is showing. So in the simple way you can say it has our open interval will always carry this less than sign. So when it comes to define any kind of values, what happens? Let us take an open interval of -5, 3. -5, 3. So when you are defining an open interval, just remember children, it has to be a common bracket. This defines an open interval. So what is the element that have been given? -5 to 3. So how can I represent in a real number? It is very simple. When you are defining the real number, so let us take a large number line, mark it as 0. Somewhere here -1, -2, -3, and here it is +1, +2, +3, +4, +5. So what is the thing I have been told? It is from -5. So I will little bit extend this element. So it can be written as -4 and -5. So when you are defining an open interval, it should be an open. That means what? When you are marking the elements of the given number line, it should not be enclosed with any kind of a given set. That is, we define it as a small term, that is this element is open. Till where it is open? Till 3. So that is positive 3. It is open. Means what? For any kind of function you are defining it, these 2 points are not included. Between these 2 points, that is -4 to +2, it is included. For each and every function you are putting the elements from -4 to +2. Then it is called as open function. We simply write it as a straight line from the open interval of the given line has -3 to -5 to +3. So this is how you define a open interval. So then how it is a closed interval? Very simple. The next part is your closed interval. So second is your closed interval. Closed interval. The condition is same. So what is the condition? For any element of y such that a is less than y is less than b, but when you are defining the closed interval, it should be an equal sign. It should be an equal sign. It is always represented by a big bracket. It is always represented by a big bracket. You can take any kind of number. Suppose I will take minus 3 to plus 2. So it should be a closed interval. What you have to do? Shade the parts where you have to locate the interval of the given line. So for example, let us take a simple line diagram. Simple line diagram. So what does it say here? So that is from the element of 0, 1 and 2, and here it is minus 1, minus 2 and minus 3. So where it is closed? That is from minus 3. So to close this element you need to fill the colors. So let us, I will take it as blue from. So it is closed. Till where it is closed? Minus 3 to plus 2. So let us take minus 3 to plus 2. It is closed. It is filled. You have to fill this. So what happens? Again draw a straight line from here to here. So while I am defining here for any kind of function, it includes these two endpoints along with the given elements. So what does it say? For example, if I take f of x is equal to minus 3x from the interval of minus 3 to plus 2 means first I will take the first endpoint. So what is the endpoint is minus 3. So f of minus 3 is equal to minus 3 into minus 3. So we will get the value of plus 9. In the same way, after minus 3, next part is minus 2. If f of minus 2 is equal to minus 3 of minus 3. So which gives the value of plus 6. So whatever the value from minus 3 to plus 2 is there, it includes in the function. So that is called as a closed interval. Next, the last two parts is open closed and closed open. Same thing, same materialistic values. So here what happens? The condition again will change. The third part is open closed interval. Open closed interval. Observe the condition here. So open and close is there. So the same condition will be there. So what is the condition? Y such that A is. What is the condition? Open. So what is the sign you have to remember? Less than. So where is this y function is residing? It is residing between the A and B value, which is closed value. A comma B. So how it is represented in a brackets? Open means a common bracket and it is closed. How it is represented. So what happens in the number line? One side is open, another side is closed. In the same way, closed open when it comes means same condition, it is vice versa. Closed open interval. Closed open interval. In closed open interval, what does the same condition says here? Y such that A closed function is there, which is less than or equal to B, and Y such that less than B. So how it is defined in the bracket wise? Closed and open. Closed and then open. So what happens in the number line? Same condition. The first term is closed and here it is open. How does it go? So these are the four intervals about subset of real numbers which we'll be using in our entire syllabus, especially in the limits and derivatives